Welcome, everyone. We'll get started shortly. We'll just ask you all to keep your mics muted unless you have any questions. But if you do, please raise your hand, and that'll be the easiest way to get your question answered. Perfect. 10 o'clock. I think let's get going here. We might have a couple more folks trickle in. But welcome, everyone. As you can see on the screen, feel free to have your camera on and really be an active participant in today's webinar. You can use the mute and unmute button to raise your hand and say hi, but please, while you're just sitting and listening, we ask everyone to keep your mics muted just in case there's any background noise or anything like that. Makes it easier for everyone to understand and to digest today's information. But yeah, let's turn over to the main slide, Adam. Perfect. So today's topic is energy fundamentals, developing an energy or a facility energy model baseline. My name's Alex Thrower. I'm a senior analyst and I'm representing Save On Energy, and joined today by Adam Dixon.
Thanks. Welcome, everybody.
A couple housekeeping things is that coming up in September we have the Save On Energy Energy Management Excellence Award, and that'll be a full day full of awards, different opportunities, different breakout sessions, and some in between kind of skills and energy sessions mixed in. So if anybody has any interest or any questions about that, the best way to stay connected is through the Q&R code you see on your screen. But you can also find any details related to that on the Save On Energy website. So please feel free to reach out there. And then also we have the podcast, which is available on all streaming platforms now. Adam, if you wouldn't mind turning over to just the next one. Perfect. Yeah, the Energy Manager's Playbook. So for this demographic here, some of you come from a very broad perspective of backgrounds, and some of you might be interested in learning more. This would be a great opportunity to start digesting some new information, or just recycling and revisiting some old one. So I encourage everyone to look out for it. It's on all streaming platforms, Apple, Spotify, everything like that. And it's a great resource, and it's going really, really well. So check it out.
Okay, thanks, Alex, for that brief introduction. So today's kind of workshop is kind of scratching the surface on energy baselines. Now, we only have an hour today. In terms of baselining, I'm going to just kind of touch the surface on a few techniques and methods and kind of how I go about doing that. So I've done thousands of these at this point in my career, so it's become a bit of an art at this point. So this will give you kind of a glimpse into baselining. I would highly recommend, if this is something you want to do or need to do for your employer, that it does take a bit of practice. There's lots of resources out there, but it does take a bit of practice. The first one I would suggest using is take advantage of the Save On Energy training and support hotline. So if you email Save On Energy, or even someone like myself or Alec, we can direct you to kind of some assistance. We can give you some coaching, kind of 2 hours of coaching to go through some of maybe your own data, go through what we talk about here in a bit more detail. That's a good resource. And there's also lots of other webinars. So this baselining webinar has kind of been built on a few previous ones, so I'll mention certain ones there. So I would recommend going back into those ones. They give you information on kind of how to gather some of the data we may use in this baselining webinar. There's also lots of training out there. Just Google this is called, I would say, energy performance training, or I'll put a link actually to one resource in the chat if you want to read up about this, some of the statistics behind it. It can get somewhat statistical heavy on this one, but I tried to keep this kind of workshop. The chat is not working for me, so I'll figure that out later. It can get very statistical. I tried to avoid that in terms of energy fundamentals, keep it as light as possible. Don't worry if you're not a statistical expert. You don't necessarily need to be to do energy baselining. Understand some basics, you can get pretty good at it. So by the end of this workshop, hopefully you'll be able to understand the purpose of an energy model baseline, identify the types of data you need to gather to create that baseline period, and then learn key variables that influence energy use. So kind of we compare our energy consumption to maybe a driving variable. Explore common methods for developing baselines. Example, the one we're going to use here is I'm going to use regression analysis, so regression and cumulative sum, or QSUM. And I'm going to use a tool called RETScreen Expert, which is widely available to everybody in Canada. And to do that, and then I'm going to discover the tools and templates to support baseline development. That's where RETScreen is going to come in. It's kind of a federal government software that is, depending on where you're coming from, very cheap, if not free to use, and is becoming growing in use as we speak, as certain softwares that have maybe been used to do this in the past from America may not be available to us anymore. So I'll move ahead to my next slide. So again, I'm Adam Dixon. I've been, I guess, knowing energy or full-time since about 2013, but I guess part-time kind of my entire life. If me and my father have a small business, so I've kind of been working with him off and on my entire life, because just as during school, things like that. So, and we've kind of been, our expertise is in this energy performance or energy baselining here. So I've done thousands, my father's done maybe tens of thousands at this point. So this has kind of become our thing over the years, is doing energy baselining. So, and just one more kind of side note on kind of logistics here. We do want your feedback on these webinars. So the survey will be sent out to you. It takes about 5 minutes to do. We do take them seriously. It's not just, doesn't just go sit in a void somewhere. We want to improve or add to these webinars to make sure people in Ontario that are involved in energy are getting kind of the training, coaching, capacity building that they need to do their job. So any suggestions you have on how to improve things or new topics you'd like to see us discuss, feel free to add that in there. So back to baselining. What is a baseline and why is it important? So it represents a state of operation within a facility that can be used as a reference period. And a word I maybe should add in here is that we want to represent a state of steady state operation in the building. It's when nothing is changing in our building. So we have changes in our building, then we're going to be, it can get difficult to kind of compare post retrofit, because typically we talk about these things after a kind of a energy retrofit has been done. So we need a state of normal operation to compare it to the state of kind of enhanced operation. Usually we try to improve our building so we have an enhanced operation. This technique can also be used to find problems in your building. We also like to see savings. Sometimes we don't see savings, we see increases in consumption. So that can be either due to a problem, or sometimes maybe we add an expansion to our building so that actually we should see an increase in our consumption. So we can kind of use that to find what's going on there. So it can be used to, it is important to identifying, validating, quantifying savings for energy projects. So on top of finding energy savings projects and identifying them, we want to validate them and quantify them for maybe even incentives. You do need to do some of these techniques to maybe validate certain savings so you can get money from incentives. And then just in general, you always want to see kind of, this is like the heart rate of your building. See, is what we're doing, is the money we are investing in energy efficiency, is it working? It doesn't always go that way. There is problems that come up. You may put something in, you may put even a lighting retrofit, which should, I mean, most of the time will save anything, but save energy. But if something goes wrong, the lights are being used more, you can see what's going wrong. And it can also be used as a diagnostic to understand buildings performance prior to retrofit. So you kind of want to see what's going on, what was going right or going wrong before these retrofits. I've done this technique with one client where their energy performance prior to retrofits was kind of very erratic. So their first goal was actually to become more stable in their pre-retrofit conditions, so they can they can quantify those. And that's also indication of waste in the building, which getting that under control will bring you savings in itself. And this can and should be changed as the building changes. So kind of on a continual improvement model. We're not stuck to a baseline once we set that. We figure out, we do all the work to get a baseline period. We don't actually necessarily want to stick to that unless you are required to stick to that by some sort of regulation. I have worked with organizations where they're required to use a certain year as their baseline, so we can do that. But I always like to tell the full story. So now you had a building with old lights in it, you put new lighting in there. So now that new lighting conditions is kind of the new normal in the building. And we can move our baseline forward. That's our new baseline period to compare to. So on a continual improvement. So any future projects are then compared to that condition. So you're not seeing you're not essentially double counting for savings there. So what is a baseline period? Why is it important continued? So this is kind of how you may see on a graph, you may have come across some of these graphs. They're kind of sometimes referred to as a measurement and verification graph. So we have our energy consumption or demand on the y-axis. We have our time on the x-axis. So the blue line here, this is our measured energy, and kind of to the left of the red square, that is our measured baseline energy. So that's kind of a normal conditions in our building. And then when you go to the right of it, this is our reporting period. So hopefully our savings period. And the green line that they've added on here, this is what once we've done a bit of statistics, this is what would happen if we hadn't have done that retrofit in that building. So, and then the blue line is our actual energy consumption. So the difference in those is hopefully savings. It can go the other way, as I mentioned, but ideally we're looking for savings here. So what we're trying to do is quantify and sum up all of this green shaded area in here. There's some techniques we can use once we kind of gather the right data to do that. So, and again, the link that I was actually going to post is at the bottom of this slide here. So this EVO World. So if you refer to the, or if you're familiar with the IPMPP, the International Protocol of Measurement and Verification, there's lots of documentation. If you are a very technical or a statistical person, mathematical, go out there. There's lots of reports on how to do this, the proper thresholds for certain values, kind of maybe even something like baseline adjustments is a common question we get. So I'm tied to a certain baseline, but my energy consumption is not normal in that period. How do I adjust for that to make it statistically valid? So lots of documentation.
And I just drop that in the chat for everyone, so there's no need to copy and paste it or spell it out. It's all there for you.
So the first step to finding a baseline is you got to get data. There's lots of data out there. Everybody's probably got some sort of data. That's maybe why you're here today, is you've got a lot of data and you don't really know what to do with it. So the first thing I always do is get historical data. And the first step I always start with is just our monthly kind of consumption data from your local utility. Get that. You can request, if you don't have any of it right now, you can request from any of your utilities 2 years back. So they will give you 2 years worth of data monthly, and probably even down to your interval data, like 15-minute data if you want it, which you could sum up and create monthly data. Now we've done in a previous webinar on historical data, accessing it and kind of organizing it. So I would highly recommend watching that. But oftentimes monthly data is the best data to use for this type of analysis. People always sometimes have sub-meters, so you're collecting 1 minute, 15-minute data. That's oftentimes, in terms of this technique, not the best amount of data. There's certain systems, kind of lags in the system, can cause issues with the statistics there. So start with monthly. Then if you need to do more refined data, depending on your situation, you can kind of create that data from interval data or from your monthly data as well. One piece of data that we often need to get also is our weather data. A lot of the times, weather is a huge driving variable in our buildings, even in kind of large manufacturing situations where people think, oh, weather doesn't affect my energy consumption. It oftentimes is a main variable on the heating side and the cooling side. And as we move towards kind of a heat pump model here in Ontario, or more electric heating, whether it does drive things on the heating and cooling sides there. Then on top of that, there is situations where there's weather and other variables that are the main drivers of energy. So as I say electricity, because this is IESO, Save on Energy, but it does happen to gas as well. So impact variables. So on top of weather, it can be occupancy, production, kind of when new equipment is brought on, if you're in a production situation, when new lines are brought on, operators, expansions, closures, changes in use, anything like that. Whether they are kind of something that changes daily, so occupancy changes daily, or something like new equipment or expansions and closures, they can be one-time events. Gather all of that data. You may or may not use it. I would say occupancy is always a good one if you can get that, or some sort of proxy for that. There is kind of workarounds to find data that you kind of can't get. So in a school situation example here is we have the occupancy. You may not be able to get the attendance of the school. All I use for that is a 1 or a 0. Is it a school day or is it not a school day? And I sum those up for the month, and that gives me my variable to tell you how that's driving the energy. Another useful tool kind of for more one-time events as opposed to events that change kind of daily or monthly is this event log. Log all of the projects you do in your building, even if it's a simple spreadsheet. So on this date, we put in this light. On this date, we replaced this motor. Have a log of that. That is very useful in terms of once you get into this data analysis to overlaying on your graphs to find potential baseline periods, because you do not want events within a baseline period. That's kind of one of the rules. So create a log. I worked with a women's clothing retail a few years ago. They had 300 stores across Canada at the time. Each store, they used RedScreen actually to do it. Each store had a clipboard in there that every time somebody came into the store that was not an employee to do work or something, they logged that. So the energy manager was able to overlay that on all of their energy performance graphs and see how did whatever we changed or whatever that repair person came in and changed, how did that affect our energy consumption? So it may not, hopefully not every time someone comes in the building it's affected, but big changes are able to be logged that way. It's not energy data, but events are very important in this. So collect data and check the data. I harp on that in our last webinar on data integrity. Just make sure you have good data there. So then we want to establish a relationship. Is there a relationship between these two variables that we think there is? And how does energy use vary with weather or some driver? So, and how does that relationship between energy use and weather or the other driver change over time? So we want to kind of look at that, create a few graphs, time series graphs, scatter plots, things like that. See, is there a relationship between these two things? We're going to dive into R squared. That's kind of maybe as deep as we're going to go on statistics today is the R squared. I think most people, well, kind of understand that as R squared. You can see on the graph here is R squared equals 0.97. So what that is saying is that our relationship we've established here is explaining 97.6% of the variation in this data. So we have a good relationship in this case between weather and our electricity consumption in this building. So we're going to use regression. This technique is called a regression analysis, and you can do it in Excel. Anything that I'm going to do here today, you can do in Excel and or RedScreen, which is another tool that I'm going to use. So if you don't want to use RedScreen, there is a bit of a learning curve to using it. Once you know, it is a lot easier, I think, than Excel. You can do all of this in Excel as well. And if you see something that I'm going to do from this step forward and you want to be able to do it, or you see a tool that I've put up on the screen here, reach out and I can kind of forward any of this data, this information, these spreadsheets, things like that to forward to you to work with. They're kind of all open source, and all of the data I'm going to show you here is real data. It's not manufactured to make it look good for these purposes. It's taken from somebody's real data, been scaled, so it's anonymous, and it is, so this technique does work. So regression is a statistical method used to examine the relationship between a dependent variable and one or more independent variables. So in the energy world, electricity or any other kind of utility, so natural gas, propane, oil, depending on what you're looking at, are always the dependent variable. They are being driven by one or more independent variables. And the independent variables, those are the weather and or occupancy, production, things like that. So kind of this is where we need to bring all of that in. And when it comes to weather, you might be looking at this screen and say, what does that CDD mean there? So that means cooling degree days. So sometimes in the energy world, I'm going to skip to, we simplify the mathematics here. So we like to use cooling degree days or heating degree days, and kind of the long story short is that creates a linear relationship. So we can use the simple math in this case. So we see y, the equation of this line here is y equals mx plus b, if you remember from high school math. So it's 326x plus 139,000 b. So that 139,000 approximately, that's kind of our base load in our building. So if there is no weather independent, no weather driving our consumption, that's our base, like kind of our base load use. And then for every x cooling degree day, we have times it by 326 to get that consumption. So we have, maybe I'm jumping ahead and overcomplicating it too much at this point. And in this model here, the first step I do is in this regression is I take all of the data. I don't worry about having a baseline period at this point. So this is, you'll see here, I think there's 36 or 38 points here. So I put all of my data in there with and without any of those retrofits that have been done. And this data, it was a lighting retrofit that was done. So we should hopefully see some savings when we get to the end here. Then what I do is I find the overall trend. Is that good? Good. We have a relationship. Then I'm going to ask you to trust me here at this next step, because I have refined that. I go into my regression. I have a candidate for my baseline period. At this point, I'm doing a bit of a leap here to show you to show on screen here. I will show you how I found this baseline equation for the first 11 months. That is, I was told by building operator, let's go with, that is steady state operation in my building. So within that regression, the rules of finding a baseline period is the baseline length. We want one cycle of the maximum and the minimum of the variables in question here. So when weather is the variable, the independent variable, that usually is about a 1 year period. So we want to see the hottest and the coldest times in our baseline period. If you have other variables, production, things like that, you don't need to use 1 year. But if weather is a variable, give or take 1 year. If you use if you don't use a year or you go above a year, you may be extrapolating and kind of not extrapolating the data. So here, basically, an example of this is if the HVAC capacity is reached at extreme cold or hot temperatures, we're actually going to see this graph kind of level off here or kind of at the bottom there. So that's where this relationship wouldn't actually explain what is going on here statistically. So if we use less than the maximum and the min, we actually don't know what's happening at those more extreme temperatures, and we may misrepresent them statistically. So make sure one full cycle of the maximum and the minimum of the variables is kind of what I like to see. You can do 2 cycles statistically, but oftentimes that could cause some issues. And don't use 1.5 cycles of the variables. Then you might be biasing your analysis towards one heating and or cooling season in this. And again, I kind of brought this up before, is why are we always using linear relationships? For the most part, if I can, I like to do it because it's simple math. There is situations where we do have to go and use a quadratic formula, and as we move towards using heat pumps a little bit more, where your heating and cooling is supplied by electricity, sometimes using a quadratic formula does work better to explain this relationship. But for the most part, we like to separate it out. That's why we use heating and cooling degree days. We can do a linear equation, easy math, and it also does represent something physically. The heat loss relationship in a building is linear. So this is kind of what we're modeling here is with weather is the heat balance in the building. We're kind of saying, what is the amount of heat in the building before the retrofit? What is the amount of heat in the building after the retrofit there? So we're just doing a heat balance there. So step 3 is once we've kind of done all of that work, we've done a regression analysis, we have all of our data in this at this point. We haven't actually jumped ahead to that first year's data. I'm going to do that in a second. We come in and we find an overall Q sum to find a baseline. So I kind of do all of the data, and then this is where I leave kind of statistics and I go to more of a science versus an art. And I'm going to actually look at the graph on the screen, get into some counting points on the screen. And I use something called a cumulative sum or a Q sum. This represents the cumulative sum of the differences between the actual consumption and the predicted consumption. So this is it may sound confusing to you. If you want a real world example of this, this is how professional golfers score themselves in a tournament. So par is the expected value, their score is the actual value, and as they go throughout a tournament. So if by the end of 72 holes in a 4-round tournament, they're at -18, for example, then their cumulative sum between the differences between par and their score is -18. And if you were to plot that on a graph, it would look similar to the graphs that we're going to see here. So this allows us to kind of compare predicted to actual. And we use that linear equation to create those predicted values. So we plot in at this heating degree days or cooling degree days, what electricity consumption should we have been using, and then we compare it to what we actually used it there. So overall Q sum, and then we plot that out, and I'm going to use Red Screen Expert to do that, and I may pull it up on the screen here to show you how I do that. It's a good candidate for a baseline on a Q sum is a stable slope. So now we're just going to look at a graph, and I'm actually going to pull up Red Screen here because it allows me to kind of show things in a bit more detail. So here I've plotted, this is kind of a very similar graph to what we saw before. So we have our regression analysis, we have our scatter plot. Don't worry about a lot of the details that you are kind of seeing on the screen here. If you're interested in doing this, there's lots of videos on YouTube out there on how to use Red Screen Expert. There's lots of coaching available, as I've already mentioned, and there's also lots of training. There's kind of 5 days of training you can also go through in Red Screen Expert, from introduction to advanced topics. So we see our equation here, and now just the way Red Screen calculates the regression results versus Excel, they are slightly different, but it is the same data set. So again, we have a good relationship. We can see that kind of over time as well. I mentioned seeing it over time. We do have a time series graph here. So we can see, yes, there is a good relationship between our electricity and our weather here. If you see kind of things that you don't expect, you do have to have a bit of kind of prior knowledge of what to expect here. So we know we have a cooling system in this building, so we should see the energy consumption go up in the cooling months here, which we do. And now in previous webinars, we have talked about how some of the things you may see in this graph may cause issues in your data. Go back and look at those if you are seeing kind of misalignment of the data that you would expect to see here. So I then create my cumulative sum. So this is my cumulative sum of the differences between the actual. So I have my actual consumption in the table below. And then I have my predicted based on that equation in the previous kind of screen I showed there. The differences between them, and then kind of the running sum here. So you'll notice there is actually a red line on here. So this entire data set is our baseline period. So what we're looking for, and we're not looking at the fine detail at this point. So at this point, I'm looking for about a year, because my weather data is my variable, about a year of a flat slope in this situation here. So all I do here is I kind of squint my eyes and I say this graph is going up and then down and then maybe down a little less flat there. That's all I'm looking for. I'm not getting caught up in the details at this point. So what I want to do, and I can close this now, is what I'm going to try to do is pull this section of the line down onto the axis. That's my baseline period. So I can see what happens to that after that relative to zero. Does it go up? Does it go down? Is it flat? Has my performance not changed? And in a cumulative sum, I think I have it on the slide. Just give me one more second. Just bring it back up. Up, down, or flat, let the data talk to you. And then again, like I said, this is art versus statistics. There's kind of a fine line. I said I'm not looking at the details right now. This is where it crosses the line into the art of baselining, is I do have to kind of ignore these little waves and these bumps here. I can explore them later, but they do, once I've found that candidate of the first year, I can come back to the slides and I can define the baseline period. So don't stress about the statistics at this point. As long as you have a relatively good R squared, you do your baseline period. You see the line go down, that equals savings. You see the line go up, that is an increased use in performance. You see the line go flat, that is returning, or that is the same as baseline performance there. So I'm going to bring Red Screen back up to see how this kind of can manifest and how I can use this for sort of that continual improvement model. So here we have our overall Q sum. And then, so I'm going to use this period here as my baseline period. So I say, okay, I think this is my baseline period. And this is where using Red Screen, it's a little bit easier than using Excel to do this. Just creating these graphs quickly and kind of automatically allows me to do this visual inspection kind of very efficiently and saves me a lot of time versus doing it in Excel. It can be done, it's just a little bit more complicated. And I do have a tool, if anybody's interested, a free tool I can give you to do kind of regression analysis with one variable in Excel. So this is our second one. So this is now our baseline period. We've now used those first 12 months as our baseline. So we now have 12 points here as opposed to 38 or 39, whatever was there before. So now our relationship between that, so our R squared is actually much better here. So we went from 97% to 99%. And now, if you're thinking back to statistics in university, you would have thought, well, 97 is pretty darn good, and by any standard that I've read, that 97 is good. The problem with it is you need to follow these steps in order to get it as high as possible, because what we're looking for is actually contained within that small percentage that we're increasing there. So because again, the entire data set we have no reporting period. So we have nothing to kind of reference backwards to. So 99554. And the reason this happens kind of physically, I'm talking a lot of statistics here, is that before, when we have all 38 points, we have the energy consumption driven by weather with lighting, with an old lighting system, which adds more heat into the building. So your cooling systems have to work a little bit harder, and your heating systems have to work a little less hard in that situation. As well as the post retrofit conditions where the heat balance is then changed. If you go from halogen lights to LEDs, you've now removed heat in that building. So your HVAC systems need to work, the cooling now needs to work a little less, and your heating would actually need to work a little more to make up for that heat that is in the building. So that's where there's a bit more scatter in the overall regression because you have all of the data points with and without that little bit of extra heat, depending on how big the lighting retrofit is. So now this is the same amount, the same heat balance for this entire period here. That's why it explains more of that line. So now when we pull that down, we can show on a QSUM here. So now we have a nice flat period. So this is kind of our baseline conditions. Your baseline, you always want it to be kind of as flat as possible here. And then once you hit that red line, which is the end of our baseline, this is where we want to see the energy performance going down. And we can see here, I've also added in kind of an event log here. So I have in red screen, I can create an event. It's just one event, it's a lighting retrofit, but I have the ability to import an Excel sheet here with as many kind of periods as I want. So I can add in, if I have then an expansion, something like that. And in this case, I may actually add in something later. So lighting retrofit commissioned. So I can see here that I've kind of start to accumulate savings at a pretty steady rate from that lighting retrofit here. And ideally, if nothing else is changing, it should be almost a flat slope, although things do fluctuate a little bit. In this situation, there's a question there. I think I'll stop. For how long, how many months should we have a flat baseline? For how many months? If it's weather that you're using, I would say 12 months is ideal. As I mentioned earlier, you can stray plus or minus a month or two. But when weather is a variable, the goal is to have 1 year. But it also depends on what this data is being used for. If you're using this technique to get money for an incentive, you're probably going to be tied to using like no less than 11 months in there because it has to be, there's very strict statistical criteria to get incentives based on this technique. If you're just trying to get an estimate for your kind of maybe internal uses, you can stray from the statistical rules a little bit as long as you know what you're doing. I have gone down myself to 8 or 9 months just to get an idea of what's going on because there is multiple changes. The situation I was in is that they did a lighting retrofit and then 9 months later they did a facility expansion. So I was kind of stuck to that 9-month period. If I wanted, without doing an adjustment, you can adjust data, but I don't like to do that. And that might be your next question. Someone's next question is, well, what if I can't get a baseline period? You can get into baseline adjustments. Let me just check if I mentioned that here. I don't think we talk about that. Yeah, no, we're not going to talk about baseline adjustments, but we have a little bit of time here. I can kind of go in there what that's doing. So what that would do, I have a graph here, is that basically what I would say is you're essentially pretending the baseline didn't have whatever retrofit was done. So for an expansion, you would subtract out whatever additional consumption that facility expansion did add to your building to create that baseline period. It is a bit of a complicated process and kind of sometimes hard to wrap your head around. I've only done it in practice a few times. I kind of use it as a last resort unless you're absolutely tied to doing a baseline adjustment. I like to tell the entire story here versus adjusting things. It's kind of smoke and mirrors, baseline adjustments. And whenever I have done it also, I do it, but I also have this real story without adjustments beside it. So I can explain both things so people kind of understand what's going on. There's a bit of the Wild West is baseline adjustments. So we see here, we have our cumulative savings here over time. And if I wanted to just get a rough savings, if I'm not worried about being statistically valid or measurement and verification, things like that, I can just go over to my final point and say, over about a 2-year period, this lighting retrofit has saved me 213,985 kilowatt hours. So then I could say, okay, if we pay 10 cents a kilowatt hour, you can say this has saved us X amount of dollars, depending on how much you pay per kilowatt hour in your situation here. Now, if you want to get a more refined estimate of savings, once we've done that, we can use measurement verification here. And that is kind of the last slide I had planned in the slides, but I think it's better to show you on the screen here. So kind of a bonus to this webinar here, measurement and verification. And then after that, I'm also going to show kind of how this technique can be used to maybe spot an issue coming up in your building. So we've used it now to set a baseline period to quantify savings. Now, maybe how can we use this to identify potential problems in our building here? So I'll do measurement and verification and then kind of use this as an early warning and things possibly going wrong in our buildings here. So we have a measurement and verification chart here. This is kind of similar to a time series chart. And as we saw earlier in the webinar, we're kind of summing up the differences between these blue and the green lines. So we have our 207,000 here because we do have an event here, and that has now been changed to the commissioning date. There is a construction period here. So we want to always make sure we don't account for construction periods. In this case, it's pretty small, but sometimes you can see large spikes in the consumption during construction or even zero consumption during construction. So just be careful with those periods. So what I like to do here, because what I saw as someone who's kind of stared at thousands of these here, is I saw this graph kind of tick down, pretty steady state, but then something in and around 2012 in the summer, this line actually went flat again. So what that indicates to me is that we returned to our baseline conditions in our building. So something potentially happened in the building, and well, okay, I don't want that to account for my lighting savings there. So when I'm reporting these to maybe city council, if you are for a municipality, I don't want them to be discounted by whatever other issue came up. I want them to know this lighting retrofit is working. And I'm assuming they didn't take out the lights to return to their baseline conditions here. So what I can do is I can end that. And then again, all of this can be done in Excel. I just find this tool a little bit easier to set dates, do things like this. It's just a little bit more visual for me. So I can do a year. Oh, that's not a year, that's a month. 12. So now I have my 1 year savings here. So it's now said this is just 1 year, 104,399 kilowatt hours for 1 year. So I could then divide that by 12 if you wanted to get your average monthly savings there. So that's how we can use kind of measurement verification to kind of accurately quantify our savings here. And I'm not going to dive into it because it is kind of somewhat scary if you're not into statistics. There is ways to see how strong this correlation. There may be someone out there thinking, well, to what accuracy is this model? We've kind of done a lot of statistics, but how confident are you in these savings? And I would say in this case, just knowing what I've done, I'm 98% confident. There's only a 2% error in this model. 98% confident that this is the savings seen from this lighting retrofit. So that's where kind of like Red Screen goes above Excel, is finding some of those statistical measures of how good these models are, how good this baseline period is, are kind of a little bit easier to work with. So what I'm going to do now is I'm going to say, well, how can I use this model for A, continual improvement, and B, to potentially spot issues that have come up in our building here. So what I'm going to do now is the continual improvement model. So we have this question before I move forward. How am I documenting different event conditions and how they relate to the graph movement? Paul, are you able to just speak up and just clarify the question a bit so I don't answer it incorrectly? Just unmute yourself and feel free to ask the question out loud so I understand exactly what you're asking.
Yeah, so as you're going through and you're looking at your graph and you're seeing, I did this and this was the output, or this was the net change up or down, or I did this and there was no change. I guess how are you documenting those inputs so it correlates to a moment of time on the output, which, as shown visually, which is your graph?
So I mean, in terms of documentation, so like just like I'm not sure I understand what you mean by documenting. So do I make notes or just like create a report
Yeah.
on what's going on? Yeah. So
Yeah, like for example, you were showing the graph, and you had your ups and downs. Hey, I did this project, and look, okay, you can see the results here. I mean, we're
Yep.
looking at just raw data. I'm just running. Are you just maintaining an open issues list so that you can say, yeah, why did the graph go up there? Oh, I did this action, and that was a result.
Okay, yeah. So I do understand. There's few things you can do. You can use this event log to do that. So I can do the events. You can also, within this graph, I can add notes. So there's edit annotations here. I can add little notes to my graph. Or in terms of RedScreen, it's kind of a little plug for RedScreen in terms of being able to use it. There's this tool called the custom dashboard. So I can kind of create a custom dynamic report that changes over time. So as I kind of drag and drop these pictures in here, I can add notes. So as things change, I can kind of document that here. So there's actually a municipality in Ontario that this custom dashboard came out of, the town of Caledon. They were kind of using this every 2 weeks. They were creating reports to document the performance of their buildings, and they only have 28 buildings, so a pretty small portfolio of buildings. So their energy manager was creating reports for each building operator every 2 weeks to document their energy performance. And they used a similar model to this. So I'd say that's kind of the most efficient one and the most ambitious one. But there is kind of, I sometimes just, some situations I have like a Word document on the side that has kind of, or an Excel document with the list of stuff as well. Hopefully that helps out a little bit.
Yep, perfect. Thank you, sir.
Okay, another question about if my baseline model's R-squared value does not fall within the acceptable range of 0.8 to 1, but I am required to use at least 3 years of utility bill data, how should I select or adjust the baseline options? So here, so you're required to use 3 years as your baseline period, or use 3 years of data to find a baseline period?
I'm required to use like 3 years. It's like it's under like some government programs.
Okay, I mean, I would, if you're required to use 3 years of data as the baseline, I would question why you would do that, would be my first response. And then if you do have to use that, might be an option. There is ways to kind of where non-routine adjustments here. So you can adjust data within that period to get the R-squared kind of in an acceptable range. What I would do first is do it without adjusting, follow all of the steps. We've kind of skipped over a few. I think you've gone through some RedScreen training, so follow the steps we've kind of gone through. See if you can get it there, then do some kind of non-routine adjustments depending on what's going on with the data. But I would also question why they want you to use 3 years, because that's going to be, you might need to do a lot of adjustments on 3 years of data. It's very rare that I've come across a building where there hasn't been changes happening in a 3-year period. So is there a reason why they want you to use 3, like a justification, other than just because?
Not really. Like I'm questioning that part too, but like, yeah, I just gotta follow what they say, I guess.
No, that's fair. But that's why I would do it, kind of follow the steps, say, okay, can't get a good baseline with 3 years of data. Now I need to adjust, and just document what data you adjust. So you can either remove base load, you can adjust the slope, things like that. It gets kind of it's not complicated mathematically, but wrapping your head around what's going on conceptually is a bit of a whirlwind there. So I'd say reach out to an expert if you're not familiar with non-routine adjustments or baseline adjustments in that case. I would also say reach out after the workshop here. We can discuss that, what I would do, and then once I can maybe see some data, maybe we'll do a coaching session or something like that.
Sure. Thanks.
So yeah, I guess kind of on that note, maybe this is a bit of a side. I do have a data set here where this is gas data, but we'll see here that we could use this whole period. This is the overall. This entire period does statistically work. So 2 years, it's not 3 years like here is required to use, does you work, but we do miss telling some of the story. Even with adjustments that are statistically valid, doing these adjustments and having long baselines, you miss telling the story of what's going on in this building. And in this case, we have a flat baseline, then things start to kind of tick upwards. And this was the indication of a boiler failing in the building. So this tick upwards, if you used more than 2 years, would have been missed. We would not have been able to maybe find this boiler failing and replace it in time. It would have cost them kind of, I think it's about 7,700 meters cubed of gas per month was extra being consumed because of this failing boiler here. So if you can do that, follow the rules, stick to that kind of 1 year baseline. You may have to do other things just to meet requirements, but always have that 1 year there in your back pocket to be able to tell the full story is kind of how I look at it. So back to our electricity data and kind of back to our continual improvement. But these questions are good because these are, I mean, people learn from them. So feel free to have more in there. We do have a bit of time here. So what I'm going to do now is I'm going to baseline this period. This is kind of the new normal in my building. I've removed those lights. I have a new normal condition in my building. I've quantified the savings. I've said I use 104,000, save 104,000 kilowatt hours per year. Now that's what's in my building now. So I'm going to duplicate that. And I'm just going to quickly do a little bit of work here. Don't worry about that, just to get a date, to set a baseline period. Don't worry about where I'm clicking on the screen and follow me along. In 10 minutes here, you're not going to be able to probably not going to be able to recreate what I'm doing. So that is February 13th, 2011. But also don't be intimidated if you see what I'm doing and you're like, oh, I'm never going to be able to do that. You will. A little bit of practice using RETScreen is pretty straightforward. And it makes your life a lot easier in terms of finding these baseline periods. If anybody's taken RETScreen training, you'll maybe know what I'm doing right there. So now I have it's not perfect here, but it is just a bit of in terms of the scale of the consumptions here. We are fluctuating a bit. So now I've pulled that. I'm jumping around. I've pulled this section of the line back up onto the axis to see what happened here. Is this just a kind of an anomaly, or did something cause us to use more electricity that we referenced back to baseline conditions? So I can see here, relatively flat. There's a bit of fluctuation going on there, but it is in the order, we're fluctuating about 12,000 kilowatt hours on 300,000 total kilowatt hours. So it is pretty flat. It's just how the graph is being rendered there. So we can see if that's our normal in our building, something happened kind of shortly after January 2012. So in April 2012, we started to see a tick up in our consumption. So if you were doing this and if you had those custom reports created, like my friend down in the town of Caledon, they would be able to see maybe after 1-2 months. 1 month could be an anomaly. 2 months, kind of start to look at it. You see 3 months of continually uptick in your buildings. Kind of maybe start asking questions. What's going on in the building? Is this necessary? It may be. It's not always that upticks are bad things. It just means maybe there's construction and I need a little extra electric heat, or there's an event going on for a few months in this building here. So over 1, 2, 3, 4, 5, 6 months, this building used an extra almost 41,000 kilowatt hours in electricity. So I would say, okay, what happened? Go to the building operators. What happened in this building? Ask questions. These baselines, these regressions, these Q-sums, they don't always give us conclusions, but they give us questions to ask as well. That's kind of one of the key takeaways to take from today is they give you questions. You may be able to answer those questions quite easily, but that should be your first step. Then it did cause us to use an extra 40,000 kilowatt hours, but what I'm also seeing as someone who stared at thousands of these, once that event was over, this graph actually ticks down at a steeper slope than the baseline. So something has improved even further from the new lighting retrofit conditions. So maybe it was a construction period to make, I don't know what would take, something that would take 7 months to install, a new chiller, depending on how big this building. This is a multi-use. This is a multi-use residential building, so it might have taken a few months to add in a new chiller over the summer, and then there maybe people were running kind of window air conditioners. That's what caused the extra consumption there. So it gives me questions to ask or things that I may think are going on in the building. I can go out there and do that. But overall, at the end of the day, they used extra 40,000, so we can quantify that, but then they also improved there as well. So we can use that. We could then get more data set, more data here. So this is only back to 2013. If I go back and approach this client, I could probably get more data and figure out what happened after that as well. So you're not tied to just one baseline period. Continually move it forward. It allows you to continually see how your building is improving or how your building is reacting to the variables. And there was another question there I'll just address now. Doesn't the ask of 3 years of data help the baseline being more representative and not skewed by a single unusual year, especially post-COVID? Yes and no. Say yes, if you have 3 years of good data where nothing has changed in the building, absolutely it can work statistically. In my experience, we don't get that much time, and 3 years is better than 2.5 or 1.5. So it's those full cycles that you won't misrepresent or skew it towards one heating or cooling season or one kind of manufacturing season, maybe a better way to say it in certain situations. So using 1, 2, and 3 years can work. Be very cautious with it, but don't use 1.5, 2.5, 3.5. Sometimes you can look at data and 18 months works, but I would recommend doing that. Not doing that, sorry. And yeah, the COVID stuff that was mentioned there. We're now thankfully further enough past that, so we can, if you go back to I use May 2022 in Ontario as kind of the post-COVID date, is that we do kind of have enough data that we can maybe move past COVID. But if you are looking back that far, there is things we can do, and RedScreen actually had built some tools right into it to help you deal with kind of COVID shutdowns, kind of anomalies like that. It was a bit of an issue. Even post-COVID, running HVAC systems a bit more does cause you to use more energy, even though you are required. So you maybe need to account for that in your performance analysis. You don't want to be penalized for things that you're required to do in your HVAC systems for regulations. So I'm going to jump back to the slides here for a second to kind of see. I think we're reaching the end here of what I had planned here. So one of the key takeaways: establishing a baseline tells the energy story of the building without bias. It kind of uses statistic that removes the bias. You're normalizing it for things. Once you've kind of gone through all the techniques, you have good statistics. It tells the unbiased story of what's going on in your building. That's, I think, the best thing to look at. And it is a robust way of quantifying savings for things like incentives. It is, if you dive into that stuff, it is kind of the best way to do that. And it allows for continual improvement, which in my opinion, is the most important. That's kind of, as we move forward, our buildings become more efficient. How do we find more efficiencies in their building? Because they are getting smaller and smaller as the projects you do. So rebaseline, rebaseline, rebaseline. And reminder, let the data tell the story first. Do not manipulate data. Do not do baseline adjustments unless you absolutely have to at the end. Tell the story unbiased, then go back and do those things that you are required to do there. So that's me done preaching for a bit. So now there is kind of, I mentioned a couple times, post-webinar support, training, monthly bulletins, things like that, training calendars for additional support. Go check those out. Email us if you have questions, but also we do have 5 or 6 minutes here. If you have any questions, I'd be happy to take those now. So the floor is now open to you guys to ask questions. Feel to type it in the chat or just unmute yourself, raise your hand, unmute yourself, and speak up.
William.
Hi, I was just wondering if you find any benefit in taking like kind of like historical data from like, you know, the coldest month and the hottest months, and just focus on that time frame.
Yeah, I have done that periodically, and actually Red Screen does have a way to deal with the seasonality on that, but it's not often there. If you have the right variables, I don't usually do that because you can account for that there. So yes, you can do that. I know I'm kind of generalizing just in the interest of time. If you want to go over that, I would say reach out and we can set up a kind of an offline chat because that would take a little bit longer to kind of go over how to do that. But it can be useful to do that as well.
And in the meantime, if there's no other questions that come up, I just want to pass on for folks that if this is your first time attending one of the webinars in the Energy Fundamentals series, this is number 4. And so the 3 others can be found on the Save on Energy website, which I linked at the beginning, where you can find the links to other recordings, but also to know that there's going to be one more event in this series. So the final webinar in this series is going to be finding opportunities in your energy data, and that is currently scheduled for October 3rd. So it might not be on the website quite yet as the ability to register, but feel free to mark your calendars for that because that is coming up as the 5th and final webinar in this series. Yeah, question from Matthew, I think.
No, it's fine. Thank you.
Okay.
Yeah, these webinars, they kind of somewhat build in complexity. So the first one, energy fundamentals, then getting the data and doing a little bit of analysis with the data. And then that last one is going to be the most technical. I'd say if you're not a technical person, don't worry. You still be able to understand it, I believe. It's designed to be that way, but we will get into doing a bit more of this regression stuff. And then we're using kind of some of our interval data. So maybe our 15-minute data, how we can use that to identify opportunities as well. So it gets into more and more numbers as we progress through these webinars. So.
As Adam mentioned at the top of the hour, please feel free to take some time to fill out the feedback form. It will be sent to you and will be made available. But also attached in the chat there are all the links that were mentioned on the previous slide, and there are other ways to provide feedback or get involved, whether it's taking advantage of the one-on-one coaching opportunities and the post-webinar support, or just staying in tune with the monthly bulletin, which will month by month have all the webinars that are coming up. And this one is quite general, but we also have ones that are targeted at energy managers or targeted at large kind of commercial and industrial folk. So stay tuned there, and all the information should be up to date. But anything that you don't get an answer for, please reach out at the training and support at IESO.ca email address, and that's the best way to reach anything related to these training series or what's available to the folks in Ontario through Save on Energy.
And in terms of that coaching stuff, if you have any questions when it comes to energy in your building, not just the topics we discussed in these webinars, reach out to that. We will direct you to somebody who has the expertise in that area. We have a pretty wide-ranging knowledge base of coaches available to you. So if you have a very technical, specific question about your situation, we probably have someone we can connect to. Also, not just baselining, not just statistics, any energy questions in your buildings.
Yeah, and I put a little bit more information about that in the chat to keep reading. Wonderful. So on that note, thank you everyone for joining us today, and have a great rest of your day.
Thank you.